Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our learning on Python. And in this video, we will solve ordinary differential equation using Python coding. All right, so we are now inside the Google Colab. We will do the coding here. So you can see, I'm going to change the title. For example, solving ODE. All right, and we create a new line of code. Very simple. And we will use NumPy first. So we will use NumPy. We should import the NumPy and we call it SNP. Okay, that's the first line. And the second one, we will use SciPy. So from SciPy integrate, because solving ODE or differential equation, it means integrating the equation, right? To get the solution. So from SciPy integrate, we will import the ODE int, ODE int, integrating the ODE, right? And the second or the third one, I will use matplotlib in order to be able to plot. All right. So if you get the solution, you plot the solution and that's it. So we will use matplotlib, import matplotlib, this one, and we will use the pyplot. So import the matplotlib.pyplot and we call it as plt. And then we define the equation, define equation. It has two arguments, time and y. The first one is y, the parameter, and the second one is time, or we call it as t. All right, and then colon. And then the ODE itself, dy dt, differential of y with respect to time. And let's say this is the function 5 times y minus 3. That's our equation. And then we will return dy dt. Okay, we will call back the dy dt. And then for example, we have the initial solution, y0, we call it y0. And the y0 is 10, for example. So we define y0 equals to 10. And then we need to describe the time, t, we call it t, equals, now we will use numpy to create linspace, numpy dot linspace. For example, the time will be from 0 to 5. Okay, so that's it, np dot linspace, right? And it will give us linear spaced range from 0 to 5. Maybe like if there will be 10 points, so 0, comma something, as much as 10 until 5. Okay, but we can skip that. We only have 0 to 5. And then the solution, y, we can get the solution by using ODE int, ODE int. This is the syntax. The first one is the function, and the function is equation defined here. All right, here equation. And then the second argument is the initial solution, which is y0. This one. All right. And then the third argument is time. All right, this one, t. Okay, that's it for the solution generation. And the next one is to do the plotting. plt dot plot t comma y. So the horizontal axis will be time and the vertical axis will be the solution or the y. All right, and then we give the label plt dot x label. For the x axis, we call it time. And for the y label, we call it y. Okay. And then lastly, we will show the plot. plt dot show like this. Okay, and then maybe you want to know the t, we can also show t like this. Okay, so far so good. We can run the code. All right, so this is the solution, y versus time. This is the plot. All right, and then this is the t from 0 to 5. You can count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 50 numbers, right? 5 columns, right? And 10 rows. So we have 50 numbers. All right. Very, very easy and very, very quick. And the good news is you can change the equation and just run again the code. Like for example, if the equation is minus 5 times y minus 3, okay. And if you want to limit the number, so for example, from 0 to 5 with 10 numbers, you can do that also. Run. Okay, so it will be like this using only 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But it will not be smooth because we only involve 10 points. Okay, so I hope you understand and we can erase that. And we change the equation from y to t. All right, this should be easier to solve with hand. Run, and the shape will be like this. All right, so we can solve the ODE very, very easily and very, very quickly using Python. All right, so I think we can call it a day. That's all. I hope you enjoyed the video. I hope the video is useful. Thank you so much for watching and see you again in the next Python videos. Thank you.